Good morning, everyone. Today we are gonna to solve our second internal test. So let's get to it. Here the first question says the population of the city in a census taking ounce in the 10 years is given. Estimate the population in the years 1925, 75, and 84. Here, the you can see the given values, years values is given here, and population in thousands is given here. So we will consider here as x and population in thousands as y. Now we solve this question. So first question is estimation of the population for the year 25, 75, and 84. To find a value near the beginning of our data, like 1925, we use Newton's forward interpolation to find value near the end or outside the end of our data. Like 75 and 84, we use Newton's backward interpolation. Like you can say if we are taking the initial values like 25, 27, or which will relate to the entry level. So we can find by Newton's forward interpolation, and for back values which are coming at the last, we will use the Newton's backward interpolation. Now we have firstly create the difference table. So as you can see, the x value which are here is given here, y is given here. Now we will calculate the first divided difference by this. So it came as 7, 16, 26, 36, 55, 55. First divided difference is calculated generally subtracting 42 minus 35, which gives 7, 84 minus 58, sorry, 58 minus 42, which gives 16, then 84 minus 58, which gives us 26, then 120 minus 84 gives 36, and 165 minus 120 gives 45, and at the end, 220 minus 165 gives 55. Similarly, we will do for second divided difference, we will do the same, like 16 minus 7, then 26 minus 16, 36 minus 26, and then 45 minus 36, and 55 minus 45. We will get the value of the second divided difference. Now, for third divided difference, we subtract uh, 10 minus 9 for 1, 10 minus 10 for 0, 9 minus 10 minus 1, and 10 minus 9 is 1. And at last, the fourth divided difference, which is minus 1, and 2. Now, for estimation of 1925 using Newton's forward formula, the base value x0 is equals to 1921. The target x is equals to 1925. So for calculating u, we will do x minus x0 by h. Here 1925 is our target value. So 1925 minus 1921 by 10 gives us 0.4. So u is 0.4. Now what the Newton's forward formula says, y equals to y0 plus u del y0, uh, u minus 1 x square, any second difference table, y0 u minus 1 by factorial of 2 plus u minus 1 u minus 2 by factorial of 3, and third degree of difference table, and u plus u minus 1 u minus 2 and u minus 1, fourth degree of difference table, divided by factorial of 4. Now we substitute the values. Y equals to y0 equals to 35, and u equals to zero point 0.4, del y0 equals to 7. Similarly, we are putting here the values here, and in third term and in fourth term. After solving this, we get y equals to 36.7424, which is our answer, and nearly 36,742 people are there in 1925. Now, for 1975, we will use the backward formula. So here, xn will be 1981 and target will be 1975. For calculating u, we will do the same, x minus xn divided by h. So here 1975 minus 1981 divided by 10 will give us minus 0.6. And formula for the backward difference formula says yn plus u, backward difference of yn plus u plus 1. See carefully here u plus 1, and in forward table there is u minus 1. So, and second order different the backward difference table. Now u plus 1 u plus 2 divided by third 3 factorial of 3 into the third degree of divided Newton's backward table. Now similarly for the fourth term u plus 1 u plus 2 u plus 3 by divided by factorial 4, and then fourth order of backward difference table. Now, here we use bottom values of the table as the backward difference table. So now substitute these values in here and calculate the value that by solving that we will getting y equals to 185.6768. It tells that in 1975 there are 187,677 people there. Now, last estimation of 1984 of this question, we use the backward difference formula, extrapolation, because it is outside the our xn value. So here xn is equals to 1981 and target is equals to 1980. Firstly, as we have done in previous two, we will calculate the u value. We calculate the u value, and so then y equals to 220. Uh, mm, okay, substitute value. Substitute the values of yn and all the formula we have written here. We will using the same formula here. So we will substitute the value and then evaluate the answer. So here after evaluating, we will be getting y equals to 238.8461, which tells that in 1984 the population will be around 238,846 people. Here we comes for the second question. Let's see what second question says. A two-dimensional table is given below. Use linear interpolation to find function 2.5, 3.5, where fxy it's given below. Now, yeah, to find the floating point in the middle of grid, we draw a box around it and will interpolate horizontal x values first and then use the new answer to interpolate the vertical y value. Now, the generalized Lagrange interpolation for two variables algorithm for 2D Lagrange interpolation is followed by multiplying two one-dimensional Lagrange interpolation together. Like you see Pxy equals to summation Lix into Mjy into a function of xi by y, where Lix is a standard Lagrange polynomial for x coordinate and Mjy is the standard Lagrange polynomial for the y coordinates. Now, in the part 2, we will use the linear interpolation to find f2.5 and 3.5. So, we identify the closest 4 points forming a square around 2.5 comma 3.1. So here function 2 comma 3 is this and 3 comma 3 is this, and 2 comma 4 and 3 comma 4 we have taken this value. Now we will interpolate it horizontally to find x equals to 2.5, since 2.5 is actually halfway between 2 and 3. So we will just find the average like f 2.5 and 3. So we will just add 2 comma 3 value, which is 51, and 3 comma 3 value, which is 61, and divide them by 2. We will get the value of f 2.5 comma 3.5. Now for f 2.5 and f4, we will do the same. We will take the value of 2 comma 4, which is 29, and 3 comma 4, which is 49, and then divide them by 39 and divide them by 22, so we will get 39. And at the final for y equals to 3.5, here you see that these two the values 3.5 will be between these two, So we will find the average of these two. So f 2.5 comma 3.5 is equals to 56 plus 39, which is a solution of these two divided by 2. So we will get 47.5 as our final answer. Now in question third, it says that integrate the function tabulated below using Simpson rule. So we have to integrate the function using the Simpson rules here. This is the trick question. Look closely. It's the X row, and the jump between the numbers is not same the whole way. From minus 0.6 to 0, the gap is 0.1. From 0 to 3, the gap is 1. We must split the problem into two parts. The interval from minus 0.6 to 0, step size of 0.1, and there are 7 points, which means six intervals, an even number. Therefore, we must use Simpson's 1 by 3 rule. So we will see the Simpsons 1 by 3 formula where it says I equals to h by 3 first plus last plus 4 odd indices plus 2 even indices. Similarly, we will put here 0.1 by 3 and first element, last element, and then the elements or odd element, and multiply them by 4 and then even indices and multiply them by 2. After solving this, we will get our first interpolated value 1.7333. Now for interval 0 to 3, where this step size we will be taking as x equals to 1. So look at the handwritten numbers in the image. F1 equals to 3, F2 equals to 2, and F3 equals to 8. Here, these are given. There are 4 points here, means three intervals and odd number. Therefore, we must use Simpson 3 by 8 rule. What is the formula for Simpson 3 by 8 rule? 3h by 8, first plus last, and 3 into the remaining points. So we'll do the same here. 3 multiplied by h divided by 8, and first is 2 and last is 8 for I2 group. You will see for I2 group, and remaining points we will add. So 3 into 3 plus 5. Now solving this equation, we will get I2 value, which is 12.75. Now final step is to adding them together. So total integral will be I1 plus I2, which is 1.7333 plus 12.75. If we, and we will get our total integral and final integrated value as 14.4833. Now we will see the question number 4. Here it is. It says the integrate function, which is 2x cubed minus 3x squared plus 4x minus 5, from minus 2 to 4, where a equals to minus 2, b equals to 4, take n equals to 4. Table of values, x, coordinates, and weights of Gauss legendary formula is given. So now Gauss legendary rule only works when integration limits are from minus 1 to 1. So our problem goes from minus 2 to 4. So we have to mathematically shrink and shift our interval, changing variable x to u. So firstly, we will transform the limits. We know what is the formula for transform the limits. It's x equals to v minus a by 2 u plus b plus u by 2. So here a equals to minus 2 and b equals to 4, and x equals to 4 minus, and it's minus 2 u by 2 plus 4 plus minus 2 by 2. So we, by simplifying, we will get x equals to 3u plus 1, and after differentiating them, we'll get dx equals to 3 du. So we will transform the function. Is original function is 2x cube minus 3x square plus 4x minus 5. After replacing x with 3u plus 1 as we have calculated here, and multiply the whole thing by 3 from dx. Now our transformed function is gu is equals to 3 u plus 1, 3 plus 1 का whole cube minus 3 u plus 1 का whole square plus 4 3u plus 1 and minus 5, and in the place of For du, we will multiply it by 3. Now we will apply the N4 rule. For a 4-point Gauss-Legendre formula, the integral is uh, approximated as summation of I equals to minus 1 to 1 wi g xi. So here summation I 1 to 4. So because Gauss Legendre with n equals to 4 provides the exact answer for polynomial up to degree 7. Our equation is only 3. We don't need to manually multiply all the decimals from the table on the screen. It will exactly equal the analytical integral. Now the here the exact calculation of integral comes. It says integration minus 2 to 4 2x cube minus 3x square plus 4x minus 5 dx. And the antiderivative derivative of this is 2x4 by 4 3x cube by 3 plus 4x square by 2 minus 5, which simplifies it to x4 by 2 minus x3 plus 2x square minus 5x. The upper limit is 4, so we'll put the value, and lower limit is minus 2, so we'll put the lower limit value, and we will get the two values. For the final answer, we subtract them 76 minus 34, which is gives us a 42. Now, here's our final question, question number 5. Here it says, write a program or draw a complete flowchart for Newton forward difference interpolation. So, we are writing the algorithm for computer can so that computer can easily read using loops. And here the step-by-step logic you can present your flow. Like firstly start. Then we will input data, read the values of n, and read data point into array xn and yn. Read the target value x target we want to interpolate. Now set up, create a 2D matrix, differentiate n, copy y array into the first column and of the matrix. D reduce I 0 equals to yi. Now uh, now we will do it. Where we are. Uh, so we will copy the y array into the first column of matrix and calculate differences nested loop. So here the loop structure is like for column 1 from 1 to n minus 1 and for row from 0 to n minus 1 minus column. Difference row column equals to difference row plus 1 column minus 1 minus difference row column minus 1. Here, calculate the step size and u. H equals to x1 minus x0 is the basic formula to calculate the difference, and u equals to the x target minus the first x target minus the first value and divided by the difference. Now we will apply the formula loop to some terms like sum equals to difference 0 0 and u term is equals to 1 factorial equals to 1. For I from 1 to n minus 1, u term equals to u term into u minus 1 minus 1 and factorial equals to factorial into 1. Now sum equals to sum plus u term into difference 0 1 divided by factorial. And after completing our loop, which was up to the n minus 1, we will print the result, display the final calculated sum, and end the program. So that's all. We have solved all 5 questions of our second internal test. That's all for today. Uh, Thank you.